Hello Year 10 and welcome to your next living room lessons. We are cracking on with our coasts topic now, which you started last lesson when we had a little bit of an introduction to how our coastline is shaped, having a look at all those different types of erosion, weathering, and thinking about how they have an impact on our coastlines. But we're moving on to something a little bit different today. So you will need your exercise book, a pen and a ruler, and probably a pencil today as well, because you're going to be doing a little bit of diagrams, and you're going to need your phone. So before we dive in, as always, let's do our jog your memory. So 3 questions today. What makes a wave the most powerful? So looking at what we did last lesson, what are the things that make a wave really powerful? Name 2 ways technology can reduce climate change. And what direction does air travel in low pressure? So think back to our synoptic charts on that one. So pause your videos now, scan the QR code or copy the link and go have a go at this quiz for me on Google Forms. So what we're moving on to today, as I've said, is we now know how coastlines are shaped, and what we're going to think about today are what some of those shapes are. Now, those shapes are better known as landforms, so we're going to be having a look at how different coastal landforms are created. So the title in your books is What Landforms Are Created Through Erosion. All right, so please can you write that in your books? What landforms are created through erosion? But before we dive into that, I want to do a little recap on what we were doing last lesson. So here is an exam question from, I think it was a couple of years ago, which explains how different things have an impact on our coastline. So it mentions erosion, it mentions bedding planes, how they have an impact. So what I'd like to do first of all is just pause your videos and copy out this little gap fill for me, filling in the gaps using some of these words here. You're not going to use all of these words, but I want you to copy these out now, and I will go through the answers in a moment. Okay, let's go through these then. So good start, Mr. Smith. Some rocks have vertical lines of weakness called a joint. The breaking down of rock by the wind and rain or by plant roots is called weathering. The force of waves compressing air into weaknesses in the cliff is called hydraulic action. And the process where rocks are picked up by the waves and thrown against the cliff is called attrition. Okay? Hopefully you got all of those correct, and we will now crack on. So our first landform we are going to have a think about is called a wave cut notch. So wave cut notch and platform. So please can you write out a little heading that says wave cut notch and platform. And I would like you to pause your videos, watch this video, and just watch it for now, soak up that pure geography for me, and we will go through something in a moment. Just to put it in a little bit of context for you, when we talk about a wave cut notch and a wave cut platform, we're talking about the kind of bottom area of a cliff and these large expanses of rock that you get at the bottom of a cliff. Often you don't see these when the tide is high. They're things that kind of present themselves when our tide goes out. So places you might see these are if you've ever been along the Undercliff walk along Brighton Seafront. So once you get to the marina and then you walk along to Rottendean and Saltdean, huge wave cut platform all along there. Or if you've gone a bit further afield, if you've gone to Burling Gap or Seaford Head, Seven Sisters Country Park, where we all should have been this week actually. Sad times we didn't get to go on our trip. Also big wave cut platforms there. So pause me, watch this vid, and we will have a talk about it in a mo. Okay, so here is our lovely diagram of a wave cut notch and platform. So here is our cliff, here is our wave cut notch found at the bottom of the cliff here, and then coming out towards the sea is our wave cut platform. What I would like you to do first of all is make a copy of this diagram with the numbers, so with the 1, 2, 3, 4, 5, and then underneath there are 5 statements here. These statements are not in the correct order. I would like you to match up these statements to a correct number, or just write them out underneath in order, so the order of which they are created. So pause your videos now, copy the diagram and write out the statements in the correct order, and I will go through the answers in a moment. Okay, let's go through our answers then. So, number one, weather from rain, wind, sun weaken the top of our cliff. So this is up here. Number two, the sea attacks the base of the cliff, creating our wave-cut notch. It attacks it mainly using hydraulic action and abrasion. Okay, those are your main two types of erosion that will erode the base of a cliff. This notch will then increase in size. As the erosion continues to happen, as the waves continue to attack the bottom of that cliff line, it's eventually going to make that notch larger and larger and larger, until eventually the cliff above the notch has to collapse. There's too much weight at the top and not enough supporting it at the base, so that cliff will collapse. And the backwash from the sea will then take that rubble back towards the sea. So it will bring the kind of rubble from that collapsed cliff will be taken back out to sea, creating our wave cut platform. So these rocks will then be laid down, creating the platform. This process then repeats over and over and over and over and over again, causing that cliff to retreat. And this is how our cliffs are retreating. This is how areas of cliff are disappearing, how the land is being lost, because that attacking from the erosion at the base of the cliff is leading to our cliffs continually retreating backwards. So as we saw from that, and a bit of what we spoke about last lesson with our weathering, it's not just the waves that are eroding the cliff. It's not just the waves that are causing this. We've also got precipitation, so precipitation at the top of the cliffs, heat from the hot summer days, cold temperatures from the winter days, and wind. So what I'd like you to do now is just do a little subheading, factors affecting cliffs, and I'd like you to copy out this little gap fill for me, matching up the factor to how it will affect the cliff. Okay, so precipitation is obviously heavy rainfall which will break down that cliff. So if there's heavy rainfall, if there's hail attacking the top of that cliff and that cliff's already been weakened by weathering, for example, it's going to speed up that process. Heat, so during really hot days when there's high temperatures, rocks will expand. Everything expands when it gets hot, okay? So as the rocks will expand, they also will then decrease when it gets cooler again. And that continual kind of expanding and decreasing, again, will break down the rock. Freezing temperatures could be, again, this is one of our types of weatherings as such. So during really cold temperatures, ice is going to freeze in gaps in the rocks, which means, again, those rocks are going to be expanding, they're going to be contracting. And then lastly, wind. So strong winds will break down the cliff. So if there's strong winds battering the top or the sides of the cliff, it's going to break down those cliff faces. And there's one other kind of main way that cliffs are eroded, and this is called mass movement, okay? So when we've had loads of weathering at the top, when the soil's become really, really damp, or when it's become really unstable, when it then collapses, this is what we refer to as a mass movement event. So could you now pause your videos and copy out the key term, highlight it so it stands out, mass movement, when soil, rocks and stones slip, slide or slump, that was a mouthful, down a slope such as a cliff, okay? So once you've copied that key term down, I want you to answer these three questions in full sentences. So what processes might have caused this cliff to slump? What will happen to the material that has slumped? And how might this affect the coastline in the future? So copy out the key term and answer these three questions in full sentences. Okay, so in terms of processes that might cause this cliff to slump, we're obviously mainly talking about weathering here. But we could be even more specific, because looking at this photo, we can see that there are loads of plants along this cliff top. So we could say that biological weathering has caused this cliff to slump, because the roots from those plants might have broken down, they made the soil unstable. What will happen to the material that has slumped? The material will be taken away by the sea. So due to the processes in the sea, those processes of transportation, those materials are going to be taken away. They might then be laid down on a wave cut platform, or they might be carried along the coastline, which we'll come to next lesson. And how might this affect the coastline in the future? So obviously we are losing areas of coastline here. We can see that this most likely was farmland. So farmland is being lost. So if the cliffs continue to retreat, if they continue to retreat because of this mass movement, we're going to be losing valuable areas of coastline. So the next landform we are going to have a look at is actually a series of landforms, and it's a series of landforms that you tend to get on a headland. So if you could do another subheading now that says arch, stack and stump, because these are our three main landforms. Now these are probably the most impressive coastal landforms in my opinion. We all love an arch. Anyone who's ever been down to Dorset and seen Dor, really impressive arch we have on the British coastline there. So what I would like you to do next is pause your videos and watch this one. There's loads of clips in this, but it's so much easier to explain coastline when there's a coastline in the video, which I don't have in my living room. So I'd like you to watch the video and first of all just make a sketch of this diagram, but leave space around it because you're going to be adding some annotations to it. Please use pencils and whatnot for your diagrams. I hope your books still look beautiful. Okay, so here are your five, I can count, 5 annotations that I would like you to add to your diagram now. So thinking about what you've just watched in that video, go back to your diagram and put these annotations at the correct point of your diagram. Alrighty, and here are our answers. So the first thing that you would have put down this end of the diagram is that waves attack the coastline and erosion, such as abrasion, is always, we say this so much. If you are ever answering a coastal question about landforms or about types of erosion, please mention a name erosion. Don't just say, erosion attacks the cliff. What type of erosion? So by saying erosion such as abrasion is quicker at weaknesses in cracks, you will have got yourself an extra mark there. So please make sure you're using these types of erosion. So that's your first one. We've got our crack been made by processes of abrasion. Over time, this leads to the crack widening, forming a cave. We could also have put in a bit of hydraulic action there because hydraulic action would have made that crack get bigger as it forced air into it. The cave erodes through the headland, forming an arch. So eventually, as the sea continues to flow through that cave, it's going to go the whole way through the headland, and we're left with an arch like so. The weathering and erosion at the base and top of the arch cause it to collapse, creating a stack. So eventually, this area here at the top of our arch is going to collapse because it's going to become more and more unstable. There's nothing underneath it to hold it up. So these processes of weathering and erosion from the bottom of the arch mean that eventually it will collapse and you are left with a stack where you've just kind of got the outcrop of your arch. And then over time, this stack will be eroded further, again by abrasion, attrition, which will turn this stack into a little stump, okay? So we just have this little stump, then eventually it will completely disappear. There'll be nothing left. And this is how our headlands are eroded and how they create these wonderful landforms. So what we're going to do to kind of finish off the end of this lesson now is we're going to do a little bit of map skills, because we haven't done that in a while, have we? A little bit of map skills to kind of consolidate our different landforms that we have just looked at. So this again was from an exam a couple of years ago. And what we have got is a photo here and a map, an OS map. Now this photo is from this point on this map, so they are the same place. Now this is quite a key skill that you will have to be able to do in geography, is to be able to look at a photo, look at a map and match them up. So work out where this photo was taken from. So the question is, figure 2.1 below shows part of the area on the map in the resource folder. I can't see it. It was taken in grid square 3085. So it was taken in 3085. So our photo was taken somewhere in this grid reference. We know that because if we go along the corridor, we get to number 30, and then we go up the stairs, 85. And we use our bottom left corner always, so we know that this is the box that we are looking at. The question then says, in which direction was the photograph taken? Tick the correct box below. So what you have to then do, and it is complicated, is use what you can see in this grid reference, in this box, to match it up to the photo. So what we can see on our photo and our map here is this quite clearly is a headland. And looking at this image, we can see that there is a headland here. And furthermore, we can see the needles, so our little stacks, our little stumps, are out to sea here. So we are looking somewhere around here out towards the Needles. So if we were stood maybe on this stretch of coastline here in Allen Bay, looking out towards the Needles, what direction would the photograph be taken in? So I'm just going to give you 10 seconds to all be sat thinking about this, shouting, maybe write it out in your books. So pause your videos, have a look at this and tell me what direction our photo is taken in. Hopefully you've all worked that out now. So if we are stood about here and we are looking out in this direction, we would be looking in a southwesterly direction. The photo is being taken in a southwesterly direction. Our next question then is, again with the same map, that same photo, name the features marked A, B and C on figure 2.1 using the map in the resource folder. So A, B and C are here. So again, looking at this area that we are in on our map, what are these three features? So again, pause your videos, have a look at the map, have a look at the photo and write A equals and write out one of these features, B equals and another one, etc. All right, hopefully you've worked that out. So A, our image here, I've actually told you this one, haven't I? A is the Needles, so A equals Needles. B is having a look at this headland, this cliff here, and if we look closely at our map, we can see that this cliff before the Needles is called the White Cliffs. So B equals White Cliffs. And then C is this inlet of water that we have to the north of our headland. So this would be Allen Bay, because we know in between headlands, if there's areas of soft rock, we tend to have bays. So C equals Allen Bays. Those of you who hadn't realised as well, or if you've not been there, you wouldn't realise, would you? But this is in the Isle of Wight. Lovely spot there. So we've got one more map skills for you to do here. And this one is with a different map. This is with our map of Derval Door, which I mentioned earlier, which is a famous arch in Dorset. So what I'd like you to do is pause your videos and answer these 4 questions using this map for me. So again, write them in your books, please, because it's really good for you to be practicing this properly. Hopefully you've had a go at that, so let's go through them. So the 6-figure grid reference of the bull. So here is the bull. As we know, we always go along the corridor first with our grid references. So going along, if we're going to the bottom left-hand corner, because it's always the bottom left-hand corner for the bull, it is 8-0. And then we have to work out how far between 8-0 and 8-1 is the bull. So if we say that that is about 5 and that is halfway, it's not halfway, it's kind of between 0 and 5. So we would probably say that it's about 803. And then we have to go up the stairs. So again, going to the bottom left-hand corner, it's actually in box 80 again. So we've got 803, 80, about 2, because it's about 2 up from our lower axes. Measure the distance between the bull and the cow. This one was quite challenging for me to do on the TV, so I've actually done it with my wee sensor thing, and I matched them up and drew on it like a ruler. And it's about 800 metres between the bull and the cow, about 800 metres. Obviously, if you were doing this properly, you would have a ruler and you would measure the distance on the ruler on your map. So you would measure out how long it is, and then you would match it up to your scale along the bottom. What does the shape of the land in grid square 8080 tell us about the geology of the coastline? So if this is 8080, whilst yes, it's asked us about the shape of the land, so you could start looking at contour lines. It's also important to note what we've been learning about. And what we can see here is a bay, and a headland. So this suggests that our geology is a discordant coastline, that we've got these parallel strips of hard and soft rock. So we could say that there's a discordant, the geology is discordant, and we've got perpendicular layers of hard and soft rock due to our bays and headlands. And we can also obviously say that there's quite steep land because our contour lines are really close together. So again, we know it's a headland, we know it's a cliff because we've got really, really steep land. And then using map evidence, explain why this area is popular with tourists. So map evidence normally means looking out for map symbols. So the things I would pick out from here is we've got parking, which suggests that people go visit it. It is a site, it's a sightseeing spot because we've got our little star, we've got a campsite. All of these things suggest to us that this is a place that people might go for their leisure time. So that is everything you have to do today, but those of you who are super keenos, which I'm sure is most of you, there's a brilliant video, it's about 18 minutes long, which gives you even more kind of insight into erosion, transportation, deposition, our main coastal processes. And it would be really good if you just watch this video, don't necessarily need to write anything down, just watch it, soak up that pure geography love, and so use the QR codes to get yourselves there. So I'll just pause it quickly for those of you who want to do that. Okay, so what you should have in your books today: coastal processes exam questions, so that exam question we did at the beginning to recap. Wake up notch diagram with annotations, the other factors that affect cliffs, the mass movement key term and questions, correct cave up, stack stump diagram and annotations, and then our map skills questions. So we've covered quite a lot today. Hopefully you've all understood lots of that. If not, do make sure to email your teachers, and I will see you very soon.